All right, guys, so before we get started, are there any questions on any of the assignments thus far? Any question on everything we've done?
Let me check.
Okay. Okay, guys. So we can try graphing this. So we can subtract 20 from both sides, which tells us that 2/3 x squared minus 6 is equal to 0. So in the graphing calculator, we can put in alpha y equals enter 2/3 x squared, what was it, minus 6 So we can see that it does intersect the x-axis at 2 points. So we can say second graph. So at -3, the y value is 0. And at 3, the y value is. So here x is equal to 3, and x is equal to -3. So this here, it worked out that we could graph it because we did have integer answers. If it didn't, then we'll probably need to use, so here we could use the square root method. Because x squared is the only x we have. We don't have x to the first power, so we can use the square root method. Any other questions on these here? Any other questions about the square root method? Yes. So the first step is what? To get x squared or the set of parentheses squared by itself. And whenever we do this, we need to make sure that one, we don't have x to the first power. We don't have x without an exponent. So we don't have, say, plus x or 3x or some term where x has the first exponent. Also, if we have x in a set of parentheses, we can't have an x somewhere else. The only variable where x is needs to be inside the parentheses. Does that make sense? So here, we can subtract 1 from both sides, which will tell us that -2x squared is equal to -7. Yeah, divide both sides by -2. Now we know that we're going to end up having to take the square root of it, yes? So we'll want to leave it as a fraction. So we square root both sides. Well, we want to try to rationalize this. So the yellow calculator will rationalize it for us. Square root of 14/2. But to type it in, we've got to split it up. We have to do the square root of 7 over the square root of 2 and hit enter, and the TI-30XS will tell us that it is the square root of 14/2. And again, whenever we take the square root, we have to add the plus or minus. Anytime we take the square root of both sides, we have to add the plus or minus.
So the fraction, we have to take the square root of the top, the numerator and top.
Any questions on any of this here? We good with this here? So let's look at this one here. So we do have a set of parentheses squared, yes? So we can use the square root method because this is the only place where x appears inside of it. Because we can get that term by itself. We can get the set of parentheses squared by itself. Divide both sides by 2, because that would give us x minus 4 squared is equal to negative 5/2. And then we can square root both sides, because, again, that set of parentheses squared is by itself, and the square root and square will cancel. Also have to take the square root of negative 5/2. Well, we could say that this is the square root of negative 5 over the square root of. So this here has no real solutions. Yeah, we can try graphing it. So we would add 5 to both sides, which will tell us that we have 2 times x minus 4 squared plus 5. So if we graph this, clear that out. When you say 2 parentheses x minus 4 squared plus 5. Where does it cross the x-axis? So where does it cross the x-axis? So what we're looking at that part is the square root of negative 5 over 2, yes? So this here is really where the issue is, square root of negative 5. Let's change negative 5 to negative 9. Because if I wanted the square root of 9, it would be what? Because we're looking, when we take a square root, we're trying to see what number times itself is the number inside, yes? So 3, because 3 times 3 is 9, yes? Because what would negative 3 times negative 3 be? Negative times a negative is a? So is there any way I can find the square root of a negative number? No. And again, if there was one, it wouldn't be what? Because what did we say that this is? So if there is a solution, it's not going to be. That's where we're starting on Monday. It's starting actually finding the solutions for these non-real solutions. Divide by? If we divide to make this positive,
Then we'd have to divide the other side to make positive.
well, let me get the eraser. Have that go away. Have that go away. And so, I mean, we can multiply both sides by negative 1. And here we would get 5/2, yes? Here we would have negative. And now I can take the square root. Well, hold on. This needs to be a 2. So this would work out fine, yes? We still have the negative over here. So at this point here, we have no real solutions. Any questions on any of this here? So I'm not going to go too much in detail with this one here, because again, factoring, we've done this. We did it in 3.13. And that's all this is. It's the same stuff we went over with factoring. And even with these here, finding it, it's the same as what we've been doing. We can try graphing it. And if it gives us 2 integer solutions, we have our answers and we're done. If not, we'll have to try factoring it, or the square root method. Factoring doesn't always work, because again, because here, factoring is not going to work, because factoring only works if we have rational solutions. So if they're irrational, we have to do a different method. So on a whole, graphing, does it work all the time? No, graphing works some of the time, yes? Factoring, some of the time. Square root method. Square root method works some of the times because it can't have a middle term. or set of parentheses squared, yes? So it works sometimes. But we will get to methods that work all the time. Zeros. We want to find where this is 0. We can, because again, all we've been doing when we solve it, we're trying to find the value of x that makes the function be 0. We're trying to find the zeros. When we graph it, we're finding the x-intercepts, which is what? The zeros. Same way, same thing, just a different way to phrase it. So 2x squared. So we can say 2x squared minus 11x plus.
I'm going to say there's 4 and then there's another one between 3, 1, and 2.
3, 1, and 2?
Which one? 1 and 2, and between 1 and 2 and 3.
Okay. I mean, the numbers that it could be, because it could be 1 and 2/3, or it could be 1 1/2, or it could be 1 and 3/5. Because it's hard to tell exactly where it crosses between those two. But what we can do is we can factor this. Now, both of our answers are going to be what? Positive, yes? Solutions. The final values of x. Where did it cross on the x-axis?
Positive.
So the values of x that we should get as the solution should be. And again, that's one of the nice things, is when we talked about graphing and the different transformations and functions where we talked about the graph of it, or I talked about that, I said this isn't something you have to know, but it does help you understand what kind of graphs we have. This is another part of it. Because even if it doesn't give us nice numbers, I know both of my solutions should be positive because it crosses at the positive x-axis. If it crosses one on the positive, one on the negative, I know one should be positive, one should be negative. And we know whatever value we get, we'll have 4, and one of them will be 1 and 2, yes? So if I get 4 in a number that's greater than 2, I know most likely that answer is not right because it's telling me here it needs to be where? Between 1 and 2. Does that kind of make sense? Yes? Or really what we're saying is here. It's going to cross the x-axis. So that'll be a solution, yes? Well, I know that this is 2, this is 1. So that answer should be between 1 and. So if I solve, and for some reason factoring I get an x is negative 3/7, we know that's not right because negative 3/7 is over here. That's not the correct answer. So it's a way that we can check it and verify that we do get the right answer. That's what's nice about these here, where a lot of the other stuff that y'all have done in geometry and stuff, we really pretty much we're using the assumption that we did it right. This is the answer. These here, we have ways to check it and make sure we got it right. Because that graph, no matter what the steps we do, is going to tell us that is the right answer. That's where it's supposed to be. Now, our signs, I think what y'all are trying to get at is that these are both negative. Because the constant, or our third term is positive, so the signs are the same and they match the sign of the middle term. Now, factors of 2x squared, well, we'll have x, and one of them is going to be 2x, yes? Did we have a greatest common factor to begin with?
No.
So would there be 1 in either one of these parentheses? Because, well, 12, 1 and 12, 3 and 4. So if I said 2 and 6, if this did work out, well, in the first one we have 2x and 2, yes? Which means I could factor that out, giving us this here. Well, if I could have factored it out of there, that means it should have factored out of here, yes? That doesn't seem too helpful, but I can't put 2 here and 6 here, correct? Could I flip them and put 6 and, well, 2 and 2x minus 6, do they have a greatest common factor of 2? Can I put 6 there? No. And the reason that this is nice and helpful is, okay, with 2 and 6, I can't put them in either way and not have a greatest common factor somewhere, right? So those don't work. And again, it could be 12 and 1 or 3 and 4. But the number of possibilities that we have to check going through factoring now got smaller, because I see, okay, 2 and 6, there's no way they can fit with 2 and 1, and it works without having some kind of factor. It also means that 4 and 12 cannot go with 2x, because 2x and 4 would have a greatest common factor of 2. 12 and 2 would have a greatest common factor of 2. You all kind of see that? And I mean, even if not, because if I had to plug, say, 6 and 2, our last step is still what? Check it, yes? 2x times negative 2 is negative 4x. Negative 6 times x is that what we wanted? So again, even if we don't notice that, our checking step will still fix it. It'll still tell us it doesn't work. That there is just one of the many steps of when, again, I said with factoring, just doing these, you'll start seeing them and doing them faster, a little bit easier. You can see how they work. That's just another kind of thing that picks up, okay, these don't work. But if we tried, say, 3 and 4, well, if this did work, I'm going to not check it here. Let's say here, x minus 4, yes? Equals 0, yes? So we would, telling me x is equal to, what did the graphing calculator tell us one of the solutions was? We can check it. 2x times negative 4 is negative 8x. Negative 3 times x is. So it does work. But again, we could have checked it and got that there. I've also solved this a few times today. So now the other one is our 2x minus 3 equals 0, yes? So what would be our first step?
You're going to want to
Add 3 and then what? So what would the answer be? 1 and a half. Yes, 3 over 2. Because we add 3 first. Then divide by 3/2. And if we look back at the graph, is 3/2 the spot where it should cross? Is that a number between these two here? Yeah, so that works. And if we wanted to, we could plug it in, because we have our 2x squared minus 11x plus 12. So we could say 2 times 3 divided by 2 squared minus 11 times 3 divided by 2 plus 12. And it does give us 0. So we don't have to put it in that fractional form. 3 over 2, 3 divided by 2 is the same thing. We get this here. Questions on any of this here? We can look at one more. That's a little bit nicer. X squared minus 8x. X squared minus 8x. Yes? So it's 0 and 8. Really, if there is no constant term, like the next one has the plus 49, if we have a number that doesn't have x with it, so for number 10 we have 49, 0 is going to be a solution. Because again, we're looking for what's going to make this 0. Well, I don't have anything else added, so it's going to be. Now, if we factored it, is there a greatest common factor between these two? x, isn't it? They both have a variable. I could factor it out, which leaves us what? X minus equals 0. We need two things multiplied together that equal 0. One of them must be. So here, x is equal to, x minus 8 is equal to, one of them is x equals 0. It's already by itself. Here we add 8 and get and that's it. Questions on this here? I'm going to give you all the rest of the time to work on the assignment. That way for the ones, because the first 4 through 8, 11, and 12, you're solving it by graphing. So while y'all still have access to the graphing calculators, you can go on and get those done pretty quickly.